Hello there. Thank you for clicking on this video. This lesson is going to cover solving quadratics with the quadratic formula. Please like this video if you find it helpful, subscribe for more math help, drop a comment or question below, and be sure to check out the other content on the channel to see what we've got to help you with your math. So I wanted to start this lesson just by talking about how we solve quadratics. So we've gone over what a quadratic is. It's an equation that can take this form right here. And of course, when we're solving a quadratic, we're trying to find the value or values of x that will make the equation true. That's what we're looking for. And there are actually 5 main strategies that we use for solving quadratics. Maybe I could have said there were just 5 strategies, and some of these are more common than others. But here's what they are. So one of those strategies is graphing, and I am going to embed a review of graphing into this lesson so that you can see what that is and maybe practice that in the practice set. Just kind of keep going back over that strategy. You can solve them using square roots, covered that in a previous lesson. So sometimes using a square root is an option for solving a quadratic. Then we get into the quadratic formula, which we're going to cover in this lesson. We've got factoring, which is probably the preferred strategy for most people that are experienced in math. Not necessarily most students, but most students, people that are experienced in math, and completing the square. Now, all of these have kind of their pros and cons. Most of the time, we use either the quadratic formula or factoring, and sometimes using graphing if we're in a pinch or we need a backup. Square roots, if you haven't watched that video, are limited in when we can use them. And completing the square will work all the time, but it's not good to use all the time. So there's certain times when completing the square is very nice to use as a strategy, and then other times when it is really not worth it. And typically what we do is if we can factor it, we will. And then if factoring doesn't work, then we go and revert to the other strategies. So let's consider this equation right here. So 2x squared plus 11x minus 6 is equal to 0. And our goal here is to solve this. We want to find out what value or values of x, when I plug them into that equation, are going to give me a true statement, namely 0 equals 0. Now, right off the bat, we can't use strategy 2 since b is equal to 11. So that square root strategy, b has to be equal to 0. If you've got anything else in there for your b value, then you cannot use square roots. So that's going to leave us without that strategy on the table. All right. Now let's take a look at the graphing. Now, see the video linked in the description box. I'll need to remember to make sure that I link that for a detailed lesson on this. So I covered how to solve equations by graphing in detail when it came to linear equations and the underlying why does this work as a strategy. So be sure, if you're not familiar with the why behind why this works, that you are checking out that video. So the first thing that we do is we're going to place the 0 with a y. So when you're using graphing, you have to get whatever equation you have set equal to 0. Okay, and I think I go over that vocabulary in that lesson. And then we replace the 0 with a y. So instead, we'll have y equals 2x squared plus 11x minus 6. Now, in that process, we have implicitly said that our y value is equal to 0. And so that is going to mean that when we're looking at our xy pairs, we are going to be looking for where the y value is equal to 0. Once you've got your equation in that form, then you go ahead and graph the equation and you find the x-intercepts. So the x-intercepts, of course, here's my x-axis there. Your x-intercepts are going to be where the graph crosses the x-axis. And I want you to note that for each of those points, the y-coordinate would be 0. So this particular equation, when I go to graph it, so this is y equals 2x squared plus 11x minus 6. You can see that there are two x-intercepts, and we can see where those are. And I had to be really careful with how I scaled this. So this is counting by halves here, if you look at where the 1 is. So this looks like there's an x-intercept at the point 1/2, 0, and then another x-intercept down here at -6. And so we have the point 0, -6. Oh, sorry, got that backwards. -6, 0. -6, 0. And again, we're looking for where the y value is equal to 0, because that was that little substitution that we made. And you can tell that there are two locations, x is equal to 1/2 and x is equal to -6, and those are the solutions. So if I were to take a -6 and plug it in here, I would eventually end up with 0 equals 0. And once you know how to do that, if you have access to a graphing utility, you have access to a graphing calculator, you have access to Desmos, this is a very, very fast way for you to get it. Now, where it doesn't always work well is if the answers are really, really, really big. So you're not dealing with 1/2 and -6. Let's say you're dealing with like 6,000. Then you run into some issues with the scaling the graph and being able to see on the graph what you need to see. But that is how graphing works. Now, just keep that in mind. Those are the answers we're looking for. We're looking for x equals 1/2 and x equals -6. So what about the quadratic formula? And you'll notice I put in parentheses here QF. So a lot of times we don't want to write out quadratic formula. We just don't want to write it out. So we'll abbreviate it QF. So a lot of times if you see QF, just keep that in mind. Somebody might be abbreviating quadratic formula. Now, see the video linked in the description box to see where this formula comes from. So it's the second video. I want to link in that description box because most of the time in Algebra 1, when we are introducing the quadratic formula, it just kind of comes out of nowhere. Like the teacher really does hand you this kind of awful formula and you just have to practice learning it. But it does come from somewhere. It comes from carrying out a series of steps to get the x by itself in the equation. And so check out that video if you want to see where the formula comes from. Now, here is the formula. Now, when I was in 9th grade, my math teacher made me memorize this, and he made us memorize it like this. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so he made us say the opposite of b instead of negative b or minus b. I think negative b and minus b are more common, but my teacher made me say the opposite of, and I have carried that over into my adult doing of math. And it just reminds you that whatever your b value is, you're going to take the opposite of it. So if b is positive, then the opposite would be negative. But if b is negative, then the opposite would be positive. So whatever that is, you're going to end up flipping the sign on it, opposite of b. Okay, now how do we use it? So how do we go about using this formula? Well, first off, you need to put your equation in ax squared plus bx plus c equals 0 form. So in order to make sure that you're getting the correct values for a, b, and c, you need to make sure that they are equal to 0. If you've got some of them on one side of the equal sign and some on the other, then you'll end up with sign mismatches on your A, your B, and your C. Now, it actually is true that there's two ways you can set up every single one of these, and I'll get into that at the end of this video. But they all need to be on one side with a 0 on the other side. So put the equation in that form. Identify your values for A, B, and C. And remember that A, B, and C are always numbers. I say this every year as I'm teaching this in my math classes, and every year I will have students tell me that A is equal to x squared or something, and so they will end up with x's floating all over their quadratic formula problems. And I've never done one with x's floating in the middle of it, but I see it a lot. So A, B, and C are always numbers, and then you plug those values into the formula. So literally, like the A goes in place of the A's and the B's go in and C goes in, and then you simplify it as much as you can. And that's usually where the wheels start to come off, because if you look at this formula, it's not a great formula. So you've got a plus and a minus thing going on, you've got a square root, you've got squaring, you have a multiple minus signs or negative symbols, and the whole thing is a fraction. So there's lots of places where this could go wrong. in terms of simplifying it, you'll see one of my pointers at the end is to just go slow. So let's start off with this problem. This is our problem that we already know the answers to. Okay, so put it in ax squared plus bx plus c equals 0 form, and you can see I already have it in that form. It might be helpful to remember that subtracting is adding a negative so that you remember that your c value is negative. So we have a is equal to 2, b is equal to 11, and c is equal to -6. I don't typically write the formula out, but again, I have been doing this for a very, very, very long time. I usually recommend that my students copy the formula down every single time and check it every single time. There's nothing more frustrating as a teacher than to get a homework assignment or a test from a student who's clearly tried to do all the work, and it turns out they copied the formula wrong every single time, and now they've got it stuck in their head the wrong way. So double check it. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You can tell I've said that out loud a lot. All right, plugging it in. The opposite of b, well, b is positive 11, so the opposite of positive 11 is negative 11. Plus or minus. And now here I'm going to do something that's it might seem a little bit odd to you. When I go to do the b squared, I am going to put the b in parentheses. Okay, it is not needed in this particular problem, but there's a reason I'm doing it. Minus 4 times a, which is 2, times c, which is -6. All over 2 times 2. And I'm usually okay with my students when they're doing something like this, if they have 2 times 2, if they just want to go ahead and write the 4. Okay, and sometimes if the squaring right here is very simple, it's like 3 squared, and they just go ahead and write 9. And I'm fine with that. Just always listen to your teacher's directions. And for sign purposes, it might, again, be helpful to remember that this is plus -4. Okay, just like a little reminder that subtraction is the same as adding a negative. And now we just have to simplify it. So this is really order of operations. We've got a grouping symbol here. That's our fraction bar is a grouping symbol. And the radical is also a grouping symbol. And the radical is contained in the numerator. So that's like our inner grouping symbol. So we're going to start with this. We've got squaring, adding, multiplying. So the order would be square it, then multiply it, then add it. Now, what I am going to do, though, is I'm going to square this and multiply this at the same time because they don't have anything to do with each other, and then we'll be able to add them together. So let's go ahead and take a look at that. 11 squared is 121. And then over here, this is -4 times 8 times 2, which is -8. And -8 times -6 is positive 48. And then I can do that denominator. So we'll do the 2 times 2 is 4. And now I need to do that adding inside that grouping symbol there. So we have 121 plus 48, which is 169. And then we'll take the square root of 169, which will be 13. And now right here, we're actually going to split the problem in half. So we know from before when we graphed it that this problem actually has 2 answers. One of those answers is going to come from adding, and the other answer is going to come from subtracting, except we can't add and subtract at the same time. So I'm going to come over here and we're just going to split this up. So we're going to have x is equal to -11 plus 13 over 4, and x is equal to -11 minus 13 over 4, and keep going. So -11 plus 13 is 2, and 2 over 4 simplifies to 1/2, which we knew was one of our answers. And over here, -11 minus 13, or if it helps, -11 plus -13 is equal to -24. And -24 divided by 4 is -6. And if you recall, those match the answers that we knew were right from doing it with the graph. So take a moment and let this problem just kind of sink in, like, ooh, does it feel like a lot of work? Yeah, it kind of does. It kind of does to me too. It does take quite a bit of time. There are places where you can abbreviate it and maybe merge some steps together, but if this is the first time you're doing the quadratic formula, I would not recommend it, because it's even longer than doing these problems once, is doing them 2 or 3 times, because you're looking for a shortcut and you just want to go very, very slowly with them. All right, but that's pretty much how it works. So you can just plug it in. The students tend to like the quadratic formula because they can just plug the numbers in and then they don't have to think too hard. So this one is in the wrong form. So this one is currently looking at ax squared plus c equals bx or negative bx. Either way, the b term is on the other side. So we're going to get that equal to 0 by subtracting 13x. And as I go to subtract the 13x, I'm going to subtract it from the middle here. So instead of doing plus 1 minus 13x, which is technically equal to 0, but the terms are out of order, I'm going to go ahead and put that 13x in the middle where I want it to be, minus 13x plus 1. A is equal to 4, B is equal to negative 13, and C is equal to 1. And just a quick little caution, make sure that you're grabbing that negative with that. All right, here's my formula. X is equal to the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. It did not take me super long to write this, so make sure you're going ahead and writing that correctly each time to get it locked in your head. The opposite of B, well, B is negative 13, and the opposite of negative 13 is positive 13. And this is where those parentheses in the last problem, I said, oh, this is like a weird little thing I'm doing here. When you are dealing with B being a negative number, especially if your intent is to use a calculator, you have to make sure that that negative 13 is in parentheses. So if you just do this, okay, your calculator is going to spit out negative 169. If you put it in parentheses, it'll spit out a positive 169. So I've had students absolutely certain that they were getting a problem right, like absolutely certain, and but they didn't put parentheses around it, and so their calculator ended up squaring the wrong number. So we don't want that to happen. All right, so we have 13 plus or minus, and we're going to start on that inside. Negative 13 squared is 169. Minus 4 times 4 times 1 is 16. And 2 times 4 is 8. And now we've got to do the 169 minus 16. So that is 153. And I'm thrilled with 153. I'm not really. But here's what I know, because I know about divisibility rules. If I take 1 plus 5 plus 3, that's equal to 9. 9 is divisible by 3. Therefore, 153 is divisible by 3. So I'm going to take 153 and divide it by 3, and that's going to give me 51. So but now I can do the same thing. 5 plus 1 is 6. 6 is divisible by 3. So I'm going to go ahead and divide by 3 again, and I get 17. So right here, okay, we want to simplify this as much as possible. 153 is 3 times 17 all over the 8. It is a square root, so we're going to be looking for that perfect square. There it is, the 3 squared. And so I get 13 plus or minus 3 root 17 all over 8. And notice that the 8 does not divide either the 13 or the 3. And in this case, you would typically leave it there. Now, there's a chance you might see something where somebody will break it up into the plus and then one with the minus. I do not typically make my students do that because I feel like that's a lot of extra writing, but somebody might have you split it up. The reason I wouldn't make my students do it is because there's nothing they can do with it after they get it split up. So if there was more simplification that you could do, then yes, but we kind of dead end anyway. All right, so a few notes. Both A, B, C work and negative A, negative B, negative C. So here's what I mean by that. If you had like 4x squared equals 3x plus 5, one of the things you might do is you might say, okay, well, I'm going to get a 0 on the right-hand side, and I'm going to do that by subtracting 3x and subtracting 5. And so you end up with 4x squared minus 3x minus 5. So your A would be 4, your B would be -3, and your C would be -5. But somebody else might look at that same problem and they might say, ooh, I could just subtract 4x squared from both sides and I'd get the 0 on the other side. And they said, that seems a little bit easier to me. In that case, A is -4, B is +3, and C is +5. And you're like, well, wait a minute, how can both of those work? Like, how can it be okay either way? Well, here's why it can be okay either way. If you go back to the graphing, here's what it would do. One of them would look like this, where you had the x-intercepts like so. The other one would look like this. And so by moving it to the other side, essentially what you would do to the graph is you would end up flipping the graph over, but the x-intercepts would still be in the same place. So you would have a different graph, absolutely. But the x-intercepts, the things that you're actually looking for, would still be in the same spot. So you're free to do whichever one you think is easier to do, where you think it's going to be easier to deal with the negatives in your problem. So just something to keep in mind there. To fully simplify, you will need to cancel out any common factors. So I have an example here. This is one where you might still have that square root in there, but if you look at like 4 divided by 4, 2 divided by 4, there are definitely some common factors there, and unlike the one that we just looked at. And so this could be simplified by simply splitting up the two fractions. 4 divided by 4 is 1, and then 2 divided by 4 is 1/2, and then you probably would not put the 1 in there. Okay, so you would be expected to carry that a little bit further. This video is already getting kind of long, and I didn't want to do more examples of that type. Couple other pointers: go slowly. Okay, use a calculator if you can. Okay, so sometimes you can get around a lot of that arithmetic by throwing it into a calculator, and just beware of shrinking fraction bars and square roots. So I've seen, here's what I mean by that. I've seen students kind of do this move where they start out with, say, the fraction bar and the root the same way, and or the full length, and then what happens is the square root gets shorter and the fraction bar also gets shorter, and that if you get too careless with that, it actually will change the order of operations, because the radical, the square root, and the fraction bar are grouping symbols. So when you start messing with how long they are, you could end up changing the grouping and what's actually considered in the group. So just be careful of that. All right, that's it. Don't forget to like and subscribe if you found this lesson helpful. Drop a comment, question below. Check out the practice set for this lesson. Make sure that you get a chance to do some problems to practice what we went over, and check out the other playlists and content on the channel. And I will see you in the next one.